Somebody wanted to see the control plan. You can see it there, but don't worry, you will see it. You see the every detail in the control phase. Right now, it is a template. And data type you already mastered with Dr. Ravi. And there are two types of data broadly: qualitative, quantitative. What you can put it using, what you can express using number, that is quantitative. What you can't express using number, that is qualitative. Can you express my name as a number?
No,
Possible, but generally no. Name means no. It is a qualitative data, but certain detail you can put it in the form of using numbers. Those are called quantitative. Again, within quantitative, you have two types: continuous and discrete. Continuous means within the range, within the profiled range, infinite number of values are possible. That is continuous. But within the preferred range, only finite number of values are possible. That is discrete. To remember, continuous data, all measurable data are continuous, all countable data are discrete. And you had this exercise yesterday. All of you have done it beautifully. So now I'm going to take you slowly into statistics. So what is basically statistics? Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. For example, at the end of the training program, we are going to conduct a test. We are going to look at your attendance. We are going to understand your participation, isn't it? So that will only help me understand, and understand what has happened, and then that will again help me to take effective decision. Hopefully, all of you will be issued the black belt certificate, right? So always we require data to take decision, and that is simply called statistics. In statistics, there are two things very important. One is central value, another one is variation. For example, all of you write the exam and somebody want to understand how effective was the training, right? And they are asking me, sir, how was the performance? What do you think I will say? I'll say, sir, this time the batch is very good. They scored, on an average, everybody scored around 80 marks. On an average, everybody scored around 80 marks. When I say everybody, when I say the average mark is 80, what is that I'm trying to convey? Can somebody tell me? Because each one of you mark I can't convey, but I can always convey average. Sir, the average mark of the student in this particular batch is 80. That means, you have performed around 80. Some of you scored above 80, some of you scored below 80, but the central value is 80. So always the central value helps us to summarize the data. The central value is otherwise called average, otherwise called median, otherwise called mode, right? And you will be learning everything. And then statistics also helps us to assess the degree of variation. Though I say the average mark is 80, it doesn't mean each one of you scored 80. There is a variation. If the variation is too high, then the statement I communicated to other person, what I said, the students are scoring around 80, may completely become invalid. Why? If the variation is too high. For example, somebody scored 60 and somebody scored 100. What is the average? Average is still 80. Somebody scored 60, somebody scored 100, but still the average is 80. But somebody scored 78, somebody scored 82, and now also the average is 80, which makes a lot of sense. The second example, isn't it? A student scoring between 78 and 82, getting an average makes a lot of meaning and sense than finding by getting the average by adding 60 and 100. So always your decision on average will sound better. Sound better means will speak the reality when variation is low. Variation is the killer in your business, everywhere. So statistics only helps us to assess the degree of variation. Variation can be understood using statistical parameters like variance, standard deviation, and range, right? And same statistics helps us to understand, explore the possible difference between groups. Now, how many groups are there? Team QFD, team PPPPK, team P-value, team DOE, and then team, what do you have? Okay. Which team is going to perform better? I want to give a cash prize of 10,000 rupees based on the way the team is performing, right? So there are 5 teams. And now, how do you want me to take decision? Which team should be given the 10,000 rupees at the end of the training program? We need some numbers, right? Probably the average score of the team, whichever team having a higher average, that will be given the cash award. It makes sense.
Yes.
So each team is made to work, and then wherever the average, because average helps us the central value, and finally the average of team A or average of team QFD, average of team PPPK, and so on. I will compare the average. There are 5 averages. Whichever average is bigger, that team will be given the 10,000 rupees. So statistics helps me to explore the possible difference that may exist between groups. Clear? These are the 3 major uses of statistics. Anything you do, you wanted to understand the central value, you wanted to understand the variation, you wanted to understand the possible difference that may exist between groups. It can be between the groups, or it can be between machine, it can be between companies, or it can be between employees, it can be between departments, or it can be between suppliers, it can be, your customers, whatever it is. If you have the basics properly, you can apply it very nicely. For example, there is a statement here. I want one of you read out the first statement. Can one of you read out the first statement?
Typical automobile in the United States travel 11,099 miles per year. The typical bus 9,353 miles per year, and the typical truck 13,942 miles per year.
What does it mean?
They are showing the average distance a typical car, a typical
Beautiful.
bus, and a typical truck travel in the country.
Beautiful. Now, immediately Sachin used the word average. A typical automobile in the United States travels 11,000 miles. It doesn't mean every vehicle is traveling 11,000 miles. The average of the travel of every vehicle is 11,000 miles, isn't it? Right? So always statistics are helpful. You can't express how many vehicles are there in US, how many automobiles? Several million automobiles. Can you show all the numbers? Definitely not possible. You collect the data, keep it in an Excel, but what will actually make sense while conveying some information is these statistics. On an average, an automobile runs 11,000 miles in US in a year, and similarly bus is running for about 9,300 miles and truck 13,900 miles. So this is how statistics is helping you. Now there are 2 types of statistics. Descriptive statistics. Another one is inferential statistics. Now, what is the attendance yesterday and today? Yesterday, I think the batch size is 25. Is that all 25 of you present yesterday?
No. No, sir, 23.
No, few absentees. And what is the attendance today? All 25 are present? Maybe a few absentees. But the information about present and past is available. Am I right? The information about present and past is available. All that I need to do is do some calculation and tell you the percentage. Yesterday's result, attendance was 90%. Today's attendance is 95%. This is called descriptive statistics. This is called descriptive statistics. And now next week, what do you think the attendance is going to be next week? Is it going to be same 90%? Or is it going to be 95%? Or is it going to be 100%? Do you have any judgment? Maybe you can have any value. You might say, sir, next week, the attendance is going to be 80% only. Now, what is that you are doing? This is an inferential statistics. You are using some data to predict the future performance. You can use statistics for 2 purposes. You can understand the present. You can understand the past. That is called what? Descriptive statistics. If you use data to predict future event, nothing has happened so far. It is going to happen. For example, I am using a machine. Last 1 year, the machine, productivity is great. Last 1 year, the productivity of the machine is great. What is this statistics? Is it descriptive or inferential?
Descriptive.
Descriptive. How my machine performed in the last year, the information is available. All that required is I must present it in a easily readable format. Maybe I can give some graph, or maybe I can summarize with some central value. So that is descriptive statistics. But having known the performance of the machine for last 3 years, can I make a judgment on the performance of the machine in the 4th year? Possible? That is called what?
Inferential
Statistics. You can use the data to understand the present and past. That is descriptive. You can use the same data to predict the future. That is called inferential statistics, right?
Sir, hello.
Yes.
Sir, there is one question. Means, like whatever the testings we do know, like the hypothesis testing, the comparative testings, all this will come in this differential statistics, or how it is, sir? Actually?
No. Hypothesis testing is an inferential statistics.
Okay.
It's an inferential statistics because you use a sample to understand the characteristics of a population.
Okay.
You use a sample to understand the characteristics of a population. The characteristics of the population is not known to me.
Okay.
If something is not known, that means you are predicting. Every time you predict, that is inferential.
Okay.
Every time you describe something, how beauty you are, you are describing. That is descriptive statistics.
Okay.
But when you only take milk, how your beauty might change after 1 year. That is prediction. So if you predict, that is inferential. But if you only describe, that is descriptive.
Descriptive. Okay. Thank you.
So now there are some numbers here. This number came from a process. This number came from a process. I don't want to do any prediction, but I want to understand the current level of the process for which I collected the data. This is then it is descriptive. Because I only wanted to understand how is my process. So I collected data. I'm going to summarize it. That is descriptive. But if I use the same data to understand what is going to come out of my process next month, then that will be called what? Inferential statistics, right? And now descriptive statistics. We have a lot of software, Excel and Minitab. I simply feed the number. It throws away a lot of statistics. The first one. What is first one? N. N means what?
Total number of
samples.
Number of samples. 12 data has been collected. Now all the 12 times some data is collected. No missing data. That is N asterisk. No missing data. Every time your quality checker goes for a data collection, he collects and comes back. There is no empty form. And now mean is 3.833. What is mean?
Average.
You know how to calculate average of 12 numbers?
Yes, sir.
How will you calculate?
Summation of the values divided by the number of samples.
Very good. Add all the 12, divide by 12, right? Or all the numbers and divide it by 12. That is your mean. Then standard error of mean. What is the standard error of mean? I told you earlier, in the examination, all of you scored average mark of how much? 80. If I repeat the exam, can my average is going to be again exactly 80?
No, sir.
But is there a chance I will get it around 80? Same exam,
Yes.
same students?
Yes, sir.
Yes.
And now will you be able to tell me some range? Sir, they scored 80, but when you conduct the exam second time, they may score somewhere between 75 and 85. It makes sense?
Yes.
Because last time it happened 80. So when I repeat, it is going to be between 75 and 85. The numbers 75 and 85 are called your confidence limits. You are very sure that based on the study you conducted, you are very sure that definitely the value is going to be between 75 and 85. But how will you calculate the confidence limit? Another statistics is required. That is nothing but standard error of mean. You will be learning it everything, right? Confidence limit, we will be teaching you. Standard error of mean will help you to calculate your confidence limit. Simply believing the average sometimes will make you a fool. You should not do that, right? When you have an average, immediately ask for the confidence limit, or you ask for the variation, the amount of variation. So that is why you are learning all the basics. And next one, trimmed mean. What is trimmed mean? Original mean is 3.833. Trimmed is 3.5. Some rounded value. I have trimmed it. Since it is trimming, I have to cut down a small portion to make it round. And so the result is 3.5. All of you understand what is trimmed mean? Right. And what is the next one? Standard deviation. What is standard deviation? The distance of each of your point from the average what you calculated. If you check it with each of the number, you will find it more or less equal. It may not be exactly. For example, the number 6. 6 is closer to 3.8. The next number 2. 2 is also on an average, it is at a distance of 2.3 from either above or below, approximately. Isn't it? So when I consider average as 4, the 6 is 2 units above. The 2 is 2 units below. Do you understand? So the distance of each of the point from the central value is measured using a statistics called standard deviation. Since there are so many numbers, since the distance is not constant, we take average of the distance. All of you are with me on this? Take the average of distance of each of the point from the central value. This is what we call it standard deviation. This helps us to understand the degree of variation in your data. More the degree of variation, the more likely that your decision on average can go wrong. Your decision made using average can go wrong. So our goal is to take decisions using average, at the same time ensuring that our variation is low. Your predictions will happen as it is, right? People will like the way you are offering solutions, right? And then variance. Variance is simply square of the standard deviation. Why should I square? Standard deviation sometimes goes up, sometimes goes down. That means sometimes it is the deviation is positive, sometimes deviation is negative. And so I square both. When I square both will become plus. That is called variance. Square of the standard deviation is variance. Sum means what? You add all the value. I think all of you are good at it, right? Adding all the value and you get the sum. What is the minimum number here?
1.
That is written, minimum 1. And then maximum is 10.
10.
So the range is 9.
9.
Understood. And now,
What is Q1 here?
yeah, Q1 is quartile 1. Quartile 1 means a point below which there is 25% of your data. That means above which there is 75% of the data. Similarly, Q2, quartile 2, below which 50% of the data, above which 50% of the data. Quartile 3 means what will be the percentage of data below? 75%.
75.
Above Q3, it is 25%. The Q2 is otherwise called median. Nothing but another central value, because below there is 50% data, above there is 50% data. It divides, isn't it? So in order to locate the quartile, you must rearrange the number first. You must rearrange the number. I am rearranging the number from lowest to highest, right? And now what is quartile 1? If the in this case there are 12 numbers, and there is a formula to precisely calculate the quartile 1. Approximately you can tell, but precisely when you want to calculate, you should use the formula. Quartile 1 is 2.25. 2.25 is not in the picture. That means the data what we are using is a continuous data. That means the data what we are using is a continuous data. If the data is discrete, whatever you see, one of it might come as a quartile, right? And now this is the formula. So mean is 3.8, standard deviation is 2.3, and standard error of mean also there is a formula. Standard deviation divided by square root of n. Standard deviation is 2.368, n is 12, and so what is the standard error of mean? 0.6835. Standard error of the mean also, you know the formula. But don't worry, all the formulas, Minitab will do it for you. Minitab is going to be your assistant after you become the black belt, right? But
Sir,
either, yes?
Sir, the standard error of mean, why it is important?
To locate your confidence limits. To locate your confidence limit, right? This is what I observed.
Okay.
But in the future, I am not very sure the same thing will observe. The same thing will happen. But I am sure, I am 95% confident that in future, the observation will be between 75 and 85. Right?
Okay.
My son scored 80 mark in the model exam.
Okay.
But in the final exam, I am very confident that he will score between 75 and 85. Now, what is this 75 and 85?
Error, standard.
Your
mean
confidence limit.
Confidence limit, yeah, confidence
Your
limit.
confidence limit. You are sure that your son will definitely get a score somewhere between 75 and 85. How do you tell this? Based on the past data. Based on the past performance of your son, you are telling. But unconsciously, you are doing all these things. Consciously, when you want to do, you should know these formulas. But I don't want you to anybody to by heart the formula here.
Okay.
Know it.
Sir,
Yes.
yeah, how to calculate this trimmed mean and where we have to use, where we should do.
Oh, trimmed mean is I just cut down a few portion and then for example, the average salary in your company is how much? Can you tell me somebody? What is the average salary in your company?
For example, 50,000.
How do you say 15,000 exactly? If I calculate the amount, will it be exactly 15,000 or 50,000? You have
No.
trimmed some portion, isn't it? You have trimmed it. You're only telling me, no, sir, 50,000 is the average. So sometimes you may have to trim your average to make it attractive, to make it look beautiful to the person, right? And for that purpose, you can trim it. Clear?
Yeah, I got that, sir. So is anything like that, for example, we have to cut down the outliers or something? It is indicating that.
No, not like that. See, trimming is like something like rounding. But when I say trimming, it is only minus. When I say rounding, it can be minus and plus. Sometimes
Okay,
we do
sir.
that. No, in billing also they do rounding. You understand? It has no meaning, but just like that, it will be rounded. All right.
Okay, sir.
And now quartiles Q1, Q2, Q3. And the formula for Q1 is N1, N plus 1 by 4th term. What is N here? 12. 12 plus 1 is how much? 13. 13 by 4 is how much? 3.25. It simply means 3.25th term is your quartile. For that, you should know what is third term. Look at the series and tell me what is third term.
2.
Third term is 2. So what is fourth term?
3.
3.25.
And now 3.25, 2/5 term is nothing but third term plus 25% of the gap between third and fourth term. Am I right?
Yes, sir.
So you said third term is 2 and fourth term is 3. And so the gap is 1. 25% of the gap is 0.25. So I'm getting 2.25. That is what the Minitab has generated here, 2.25. Clear? Formulas are there. No, you can calculate, but we don't have time. So we will make the softwares to generate the report for us, but we should know what the software is doing. If you don't know what the software is doing, do you think the number will be helpful to you?
No, sir.
That is why, most of the people, even after training, they are not effective. You must learn the basics. Then, try to cut down your time and everything. Do a,
Sir.
Yes.
Third term plus 25%, how it come 2.25? N plus 1 divided by 4 equal to 3.25.
Yes.
And third term plus 25%, 2.25.
25% of the gap between third term and fourth term. You must listen very carefully every word I'm spelling. Third term plus 25% of the gap between third and fourth term. That is what I said.
Okay.
So what is the gap between third and fourth?
1.
1.
So what is 25% of 1?
0.25.
And so the answer
Two
is
plus
0.25.
2.
Right. So you will understand. Don't worry. You can watch the recording again and again, and then you can also do it. Clear? Shall I move on? Shall I move?
Yeah.
Yes, sir.
Right.
Sure.
Now quartile 3, there is a formula. 3 into n plus 1 by 4th term. Again, n is 12. 12 plus 1 is 13. 13 into 3 is 39. 39 by 4 is 9.75. It simply means 9th term plus 75% of the gap between 9th and 10th term. What is 9th term here in your series of data?
4.
4.
4. So what is 10th term?
5.
So how much is the gap again?
1.
So 9.75th term is nothing but 4 plus 75% of the gap, and so it is 4.75. Do you see quartile 3 is coming as 4.75? All right.
Yeah.
And then
Yes.
interquartile range, it is nothing but Q3 minus Q1. Q3 is also known, Q1 is also known. The difference is 2.5. That is what you are seeing here, 2.5. Clear? And now mode. Mode is the most frequently occurring data. What is the data which is frequently occurred?
3.
3. And so mode is 3. So what is the color of the shirt? which most people are wearing in the program, in our training program? Can you tell me?
Black.
So black is the mode here in terms of color, right? So sometimes mode will help you to understand what people likes. Always the central tendency will only will let you better understand what people are thinking, what your process is thinking, what people are doing, what process is doing. So mean, whenever you want to understand the central value, use the mean, use the median, or use the mode. And now you can visualize all this information using a graph. This graph is called a box plot. This graph is called a box plot. The box plot will have 3 horizontal lines. First horizontal line, this is quartile 1. The second horizontal line, this is quartile 2. The third horizontal line, this is quartile 3. Quartile 2 is otherwise called median. Median is sometimes n by 2, sometimes n plus 1 by 2. Sometimes it is n by 2, sometimes it is n plus 1 by 2. So it depending on the number of data, right? And now the first 25% of the data lies here. Second 25% of the data lies here, and then or otherwise the third quartile is this much, and then this is the fourth quartile. One star is given here. This star is called this is
Maximum value.
Outlier.
This is called outlier. Why do I call it outlier? Because most of my values are around the center value, but only this value is far away from the center value. So I call it an outlier. That is why it is projected separately. It is definitely not a part of the population. It is definitely not a part of the population. So always when outlier comes, that indicates that your process is definitely under influence of some mistake. Only some mistake has happened. That is why your process produced this output. Too much of deviation means there is a problem. Too much of deviation means there is a problem. The problem could be simply people could have documented it wrongly, or your process could have been affected by seriously some mistake, right? So we will be always outlier requires investigation to understand, and including outlier in your calculation is always not recommended, because outlier is not your regular output. Outlier is not your regular output. We want to understand what is the regular performance of my machine or performance of my team. So outliers always should be excluded. And these lines, the bottom line and top line, these are called whiskers. These are called what? Whisker. There is a whisker down and there is a whisker up. What is this line called?
Whisker.
What is this? Whisker. Whisker, not whiskey. This line is whisker, right? There is a line here, and this is only helping you to understand the parts of the box plot. So visualizing the spread of your data.
Is it like a candle chart which is using in the stock market?
Candle chart, right?
Yeah, candle chart.
No, you have to show me. Maybe no, you can give a different name depending on the shape, but this is called box plot. Maybe it look if somebody can call it a candle chart if something looks like a candle. But sorry, I have not seen the candle chart.
So inside in the box only 50% population, correct, sir?
Come again. It is
inside the box only. It is 50% population.
Yeah, you are right. Inside the box it is 50%, and below the box there is another 25%. Above the box there is 20. Gives an idea about how your data is distributed. Right. So we understand descriptive statistics are the methods of organizing, summarizing, and presenting data in an informative way. And if you use the data to summarize the past population, your approach is called descriptive statistics. Right. I think this example is not required. You already understood what is descriptive statistics. Any information about what has happened in your organization, that is always descriptive. For example, your last year balance sheet you are releasing. What is that? Descriptive statistics, right? But next year profit, anticipated profit, that is inferential statistics. So inferential statistics are the methods to estimate a property of a population based on a sample. But that property is not known to me. I want to understand. And so I take a sample and predict on the population. For example, I want to understand on an average, what is the salary of a person in the age group of 30 to 40 in a city called Mumbai. In Mumbai, what is the salary of people in the age group of 30 to 40? Will I be able to talk to each and every person in Mumbai in the age of 30 to 40? I'll take a sample. I'll take a sample and then I will document the salary and then I will calculate the average. And with that, I will make a judgment of the millions of people or lakhs of people, in Mumbai. So I understand that the average salary of people in the age group of 30 to 40 in Mumbai, their average salary is, let us say, 60,000 rupees. Now, what is this called? This is inferential. Before the study, I was not knowing. I don't know whether the salary is 60,000 or not. But now I know. So that this way of statistics is called inferential statistics. If it is already known or it is available, you only just wanted to understand, then it is descriptive. So you can use this inferential statistics in a lot of way. It is used in business, it is used in agriculture, it is used in politics. Which party is going to form the government next year? Now itself people are telling how they have done some survey. What is that survey? That is a sampling. So use a sample to predict the population. That is called what? Inferential statistics, right? And use the already available information, present it nicely. That is descriptive statistics. Hope it is clearly understood. And then how do you collect the sample? That is also equally important. Probably you may again learning the sampling techniques again in the measure phase, but only broader way I will tell you. So you can collect the sample in a what you call random way or in a non-random way, right? Random way means it is called a probability sampling. Non-random way means it is called non-probability sampling. For example, I want to ask a question and suddenly I call one of you. Maybe I call Raja, right? I call Raja and ask him a question. Raja, what is the difference between descriptive statistics and inferential statistics? What is your opinion? Raja, are you there on the video? Yeah.
Yes, sir. Descriptive statistics is whatever information available in the previous.
Yes. Information already available, that is presented.
Yeah.
It is available, but probably for some reason I have not understood properly. But now I present it. That is descriptive.
Inferential, right. What we are going to predicting the future.
Yeah. So now I randomly picked up Raja and then asked a question. So this is a probability sampling. There are 25 people, but I picked up Raja. This is called what? Probability sampling, right? And then always, I can go with the non-probability sampling also. For example, I will tell, all of you, maybe I will exactly say, people, I will have some rule. Let's say those who have the name starting with the letter A, you will be asked the question, right? And that way when I go, that is called, non-probability sampling. So we'll see that. So random means what I demonstrated now is the random. You pick up a sample from the population in a random fashion. And then non-random. And non-random means you see here, there are so many samples. The third sample is selected and then the sixth sample is selected. For example, there are 10 machines. You collect data from the third machine and then you collect data from the sixth machine. Right. This is called non-random. This is called non-random. So now if you have a formula for sample selection, that is non-random. But no formula, you can pick up anything, that is called random. And then there is also two types, stratified sampling and cluster sampling. And now there are, let us say 1, 2, 3, 4, 5, 6 groups are there. Or like in a class, there are 6 benches. Every bench I am selecting one student and asking a question. Every bench necessarily I am asking a question. Now this is stratified sampling. But in another classroom, there are 6 benches, but I picked up only the second bench, but I asked the question with all the students in the second bench. All the 3 students are questioned. Now this is called a cluster sampling. Sometimes I select 2 benches and then ask the question of, to each students in each bench. So that means I selected 2 cluster and then every single unit inside the cluster is audited. So this is called, cluster sampling. So you just have to understand the different types of sampling, because I do not know which particular way of sampling will help you to better understand the population. For example, I want to understand, how are you performing? And based on that, we want to give you the certificate. Tell me, do we need to assess each one of you, or no, only a few of you can be assessed and then certificate can be issued? Which is a better way?
Each one.
Each one.
Now sampling is not helpful to me. Please understand. Now sampling is not helpful to me. Why? The population size is just 25. Rather, I will study each sample. I will study each sample and then a decision can be arrived. So you need to know when doing sampling will make sense. If you understand sampling will make sense, and then what kind of sampling will speak better? What kind of sampling will speak better, right? So there are different types. So you will be again, learning each and everything. And similarly, convenience sampling. What is convenience sampling? For example, when I want to interact, I will interact only, with the people who are on video. People who are on video, isn't it? So it is convenient for me. Similarly, when I have to do a study, do a survey, people around me, I will pass on the questionnaire and then quickly get. I'm doing a survey. I collect the survey. I fill up the survey forms within my company, because that is easy for me. That is called convenience sampling. But will it have some disadvantage also? It may have advantages. You quickly get it filled, but disadvantages, it may not capture the entire, the spread is not proper. The spread, everything, within your company. So whatever the finding, that can be applied beautifully to your company. But if your study is on the whole city, then what you are doing may go wrong. So you have to make a choice of the correct way of sampling. And purposive sampling. What is purposive sampling? I ask few questions only to Raja and then only to Bajish. You know why? Because they are our old student. There is a purpose, right? So similarly, when there are three units available, the 10 machines available, purposely you select certain machines, maybe the new machines, because your supplier, your one of your customers came for the inspection. Probably you will show all your new machines, not the old machines, isn't it? You will collect a sample only from the new machines and then show it to your customer. So that is called purposive sample. And then voluntary response. I put my survey form in a social media and anybody can fill up. Anybody can fill up my form. Now, what is my sampling? Voluntary sampling, voluntary response sample. And then snowball sampling. What is snowball? I interview somebody, get my questionnaire filled, and then ask for a reference. Now he gives me another reference. Because that particular profile of people, I really do not know much people. He may be a sports person or he may be a film star. My survey is about the film stars. So one film star somehow I got luckily. And now I'm asking the reference. Now he gives another 3. And now this kind of sampling is called what? Snowball sampling, right? So this is some idea about sampling.